This video covers double replacement reactions and how to predict the products of a double replacement reaction. Let's review for a moment about what a double replacement reaction contains. A double replacement reaction is when you have ions of two compounds exchanging places in an aqueous solution. Remember that aqueous means to be dissolved in water and will be indicated with an AQ as a state of matter. This is going to become important when we are predicting our products. Our reactants are all going to switch partners with one another, and here's our general equation for a double replacement reaction, which can be found on page 6 in your reference table, so make sure that you have your reference table handy. Here we have an AB plus CD yields AD plus CB. Notice how the B and the D switch places. Your products will often contain water, it could contain a gas, or it can contain a solid. We're really going to focus on if our products are going to produce a solid or not. Remember, we call this a precipitate. Here is a general normal double replacement reaction. Here we have lead nitrate plus potassium iodide yields lead iodide and potassium nitrate. As you can see, your nitrate and your iodine are switching places. When you are predicting your products, an easy way to know who's going to be paired with who is your outside elements are going to come together and your inside elements are going to come together. And I'll show you a little bit more about that on the next slide or two. Here's another example of a double replacement reaction. This is a special double replacement reaction. This is when you have an acid and a base neutralization. A base, remember, is anything that has hydroxide at the end of the formula, and an acid is anything that has a hydrogen in the front. We can still do this neat little trick where we can have our outside elements come together and our inside elements come together. Notice how as a product we have sodium chloride and water. Another way that we can write water is HOH, so hydrogen hydroxide. But if we rearrange this a little bit, we have H2O. Either way, they are the same thing, and we can still use our neat little trick to produce or to predict our products. Now, the one tricky part about your double replacement reactions is being able to read your solubility rules on page 6. So, for double replacement reactions, you need to be able to read and understand your solubility rules. Okay? Down here in your reference table, we have our double replacement reactions, and notice how we have two different types. We have the formation of a precipitate from a solution. A precipitate means that you have to have a solid in your answer. If you do not produce a solid, you will not have a chemical reaction for a 4A chemical reaction. For a 4B with your acid-base neutralization reaction, you will always produce a salt. And remember that a salt is any ionic compound as long as you cross your charges. So we need a metal and a nonmetal. So you're going to produce a salt, and you will always produce water for an acid-base neutralization reaction. Now for a 4A, you have to use your solubility rules up here at the top to see if you need, or which one's going to be soluble and which one's going to be insoluble. So here's a closer look within your reference table. And again, the toughest part about a double replacement reaction is being able to read your solubility rules. If it is soluble, that means it will dissolve in water, which is where we're going to indicate an AQ for aqueous. If it is insoluble, that means it will be a solid in water, so we're going to put an S for those. But these can be a little tricky. I'm not a big fan of how these are worded in your reference table, but we're going to try to get through it the best that we can, which is why I said have your reference table right next to you while you're watching this video and while we are practicing our double replacement reactions. Okay, so keep this next to you. That way, when we are answering those questions, you can just refer to it. The trickiest part is where it says except. So all these are soluble, chlorides, bromides, and iodides, except when you have silver chloride, or lead chloride, or mercury chloride, silver bromide, lead bromide, mercury bromide. If it is paired with one of these, that means it's insoluble and will be a solid. Where it says group 1 salt here, that means anything in group 1, so any ionic compound that contains lithium, sodium, potassium, rubidium, caesium, and francium, that would be considered a group 1 salt. All of your sulfates are soluble except for when you have calcium sulfate, strontium sulfate, barium sulfate, mercury, lead, or silver sulfate. All of your fluorides are soluble except when they are paired with group 2 elements. Group 2 elements would be beryllium, magnesium, calcium, strontium, barium, radium, all those good things. If it is insoluble, you have that list over here, and again, we also have some exceptions, so make sure that you're paying close attention when you're trying to predict your products. Alright, so let's start with the easiest one first. That's going to be your neutralization reaction. Your neutralization reaction is going to involve an acid and a base. This in your reference table is a 4B chemical reaction. Remember that your acids are going to start with H. Your bases are going to end in OH. You're going to produce water, always, as a product. And then you're going to have a salt. And your salt, remember, can be any ionic compound. So this is going to be your metal and your nonmetal. And make sure that when you write these out, that you're checking your charges to make sure that they equal 0. Okay, so again, your acids start with H. Your bases end with OH. So let's try a couple. Here's hydrochloric acid. I know it's an acid because it has the H in the front. And here's sodium hydroxide, which is our base. Both of these are aqueous in water, indicated here by AQ. Now, when you are doing your prediction of products, use that neat trick where you can do the outside comes together and the insides come together. So you're switching partners here. So I'm going to have water. This is my HOH, which I'm just going to write H2O. Plus my sodium and my chlorine. I'm checking my charges because it is ionic. Sodium has a +1 and chlorine has a -1. So here is my salt, which is sodium chloride. I'm going to check to make sure that this is balanced. I have 2 hydrogens, 2 hydrogens, 1 oxygen, 1 oxygen, 1 sodium, 1 sodium, 1 chlorine, 1 chlorine. We are balanced and ready to go on to the next question. Here's number 2. We have hydrobromic acid plus calcium hydroxide. This is going to be my acid because it starts with H, and this is going to be my base because it ends with OH. I'm going to use my neat trick here where I'm going to have my outsides come together and my insides come together. So my HOH is going to create water, which is H2O. And then I'm going to have calcium bromide. I'm checking my charges. Calcium has a +2. Bromine has a -1, so when I write this chemical formula, I have calcium bromide, so CaBr2. I'm going to check now to make sure that this is balanced. It is not balanced. I can automatically tell because I have 2 bromines here and 1 bromine on my reactant side. So I'm going to place a 2 coefficient here, and now I'm going to see if it's balanced. I have 1, 2, 3, 4 hydrogens, and I have 2 hydrogens over here. So let me place a 2 here. Okay, so now I have 4 hydrogens, 4 hydrogens, 2 bromines, 2 bromines, 1 calcium, 1 calcium, 2 oxygens, 2 oxygens, so I am balanced. Let's do one more, and then we'll move on to the next type of chemical equation, or next type of double replacement reaction. Here I have copper hydroxide plus, I'm thinking that this is perchloric acid. Yes, it is. All right. I'm going to use my trick here where I'm going to do my outsides together and my insides together. I have the HOH, which is water, so I have H2O. I know that I'm going really fast in this video, guys, but remember that you can pause it if you need to and rewind it. And you can always send me an email with your questions. And then my outsides, I have copper and perchlorate. Now, copper is a transition metal, so I have to figure out what its charge is. I'm going to use the cheat way. Y'all know what the cheat way is. I'm going to look here at this subscript, and I'm going to say it belongs to copper. Okay, so copper has a +2 charge. Perchlorate, has a -1 charge. So when I write this out, I should have Cu, and then I have chlorate, C perchlorate, LO4, with a 2 on the outside. And now I've correctly predicted my product. I'm going to check to make sure that it is balanced. I'm going to start with my metals, because I'm going to do minnow. I have 1 copper, balanced. I have my ions, chlorate. I have 1 chlorate here, and I have 2 chlorates here, so I'm going to place a 2 right here. So I have 2 chlorates, 2 chlorates. Alright, so the ions are balanced. I have how many hydrogens here? Let's do oxygens first. I have 2 oxygens, so I need a 2 here. And then that should give me 4 hydrogens, and it does. Alright, so now I'm balanced. I just need these 2 coefficients here. Okay? I want you to try to do number 4 on your own. We have sodium hydroxide plus sulfuric acid. We are going to cover the next double replacement reaction where you have to form a precipitate in the next video.